Alright, so good night guys. I'm going to start by talking a little bit about the last section. So I had some troubles with exercise 30 and I had done exercise 28, so I did exercise 29 as it was recommended to me. And yeah, it was pretty simple, that's why I skipped 29, but just to be sure. Then when I was in exercise 30, funny thing, first I did exercise 29, you can see it here, and it was pretty simple. And the reason why I had some questions about exercise 30 was that, for example, if f is a function from s to t, then it means that not all elements of s are used in this function. So yeah, because in t I know that not all have to be used, because if all of them are used, then this is a special function, because we say that the function is onto. And then I have another question, because all of s has to be used, or the set from where you start. Well, how about a function like 1 over 1 over x? What about the case where f of 0, does it get an undefined, and so does, in this example, does t have an element called undefined, or what happens? So yeah, that was my question, why I wasn't understanding. And well, after this I can say that one-on-one of a set S into itself, it means that it's onto, so it's bijective, and also the other way around, so if it's onto, it's also one-on-one. And for exercise 30, I crossed this out, which was what I did yesterday. This also stands, but doesn't really matter. Let's see what I did here. So we know it's one-on-one and onto. So I first considered this case, like if f is if f is the identity, then f of s would get s. So for that case, we know that it works. But in the case that f of s isn't x, so it isn't the identity function, then we know that it is another element of s, of set s. So we know that then that f of this element has to be some other element, and if it ever comes back, and it can't ever come back because of this. I thought that this was a counterexample, but then I realized, because I thought, well, f of 1 goes to 3, then f of 3 goes to 1, this makes sense, but what about the case f of 2 goes to 2? This will never be reached. But then I realized that, well, f of 2 equals 2 is already this already works. So yeah. So we either get this case, which is the identity, or we get this case, and this case is probably has more steps. For example, f1 equals 3, f of 3 equals 4, f of 4 equals 5, f of 5 equals 1. But in this case, wherever we get, we can always, like, it rotates from whatever set you have, it will always rotate and eventually get there. So okay, next one, exercise 41. If S has m elements, find an n bigger than 0 in terms of m that works simultaneously for all unknown mappings to itself. So funny thing, exactly like this one, where I started by showing why it wasn't possible, I realized why it was and how to get the answer. So initially I thought, wait, not this. Wait, what did I think? Okay, let me reread the question. Okay, yeah, so I don't remember why I thought this one wasn't possible, so I'm just going to reread this. Um, yeah, I thought. So for example, if you have a for example, this one, if you have this function, well, in this case, the identity, it will always take n equal 1. And in this case, it will always take n equal 2. So we can't do n equal 1 and 2 at the same time. So then I realized that maximum multiple, common multiple, would be of the number of times that each that takes for each element of S to rotate or to get back to the identity function. So I did the maximum multiple common multiple, and this way I know that if for every n equal this, it will all be the identity function for everyone. And this was not really well explained, but I was writing this while I was thinking, and eventually got to the answer. So yeah. So after this, I read the section A of S. A of S is basically the set of all sets that that are like permutation. So all possible ways that that S is onto itself, and so bijective. So yeah, it's a set of all the sets that are possible. It has some properties, then it shows some more properties, and I did these ones looked simple, or well, I knew exactly what to do from the start while I was reading. While here, I don't know if it's because I'm tired or what, but I read it was like, I don't know. So what I did was write up the problem first, and then well, there isn't much to talk here. I think I'm just going to show the answer. Going to re-show the question in case you couldn't read it. Yeah, here. Also part B, pretty much the same. This one isn't really hard, but I had to think a bit about it. Not sure why. Guess it wasn't obvious for me. Maybe I'm tired, I don't know. Not exactly worth explaining why. I think it's like kind of straightforward. But then exercise 4, I could still do it. So again, this all started by me like not understanding something, and in this case, what does this mean? So this means that exactly we are missing after. So f negative 1 g f after f negative 1 h f. So after I realize that this happens, well, then I could remove or make f times inverse of f and substitute it by identity function. So yeah, that's how we got there. And for what can you say about f negative inverse of f g f all elevated to n? Well, then I just expanded it and realized that it would get to this. For exercise 5, I couldn't do it. Maybe I'm tired, going to sleep, I don't know. Fg belongs to A of S and Fg equals G of F. I'm not sure why is this. I think it's related to this, and I really don't know. So yeah guys, thanks for watching and goodbye.